Let's solve this word problem using the knowledge of quadratic relations. A computer store sells 50 laptops every month at a price of $900 each. A recent survey shows that they can sell 2 more laptops for every $20 reduction in price. What price should they sell their computers at to maximize their revenue? So what we have to do is we have to do a variable assignment statement. So we need to say assign a variable for the number of $20 reductions. So I'm going to do let x equal to the number of $20 reductions, price reductions. So now what we have to do is we have to come up with an expression for the price of a laptop after the reduction and the total number of laptops that would be sold after the reduction. So let's write that expression. So price of a laptop after a $20 reduction would be the initial price is $900, and if we are going to have X number of $20 reductions, it's going to be, so for each X, for each reduction, it's going to be $20, so it's going to be 20X. So that would be the expression for the price of a laptop. And now we have to find the total number of laptops that we would sell after the $20 reduction. So if we usually sell 50 laptops, and if we reduce the price of a laptop by using like the $20 reductions, we'll sell 2 more. So for every X number of $20 reductions, we're going to sell 2 more laptops. So it's going to be 2X times. We would sell that many laptops more if we have X number of reductions. So now that we have the price of our laptop and the total number of laptops that we sell, we can write an expression for the revenue. So the revenue would be the product of the price of a laptop times the total number of laptops that we would sell. So now I'm going to find an expression by finding the product of these two. So let's just sub in the values, 20x. And I'm going to multiply that by 50 plus 2x. Now I'm going to use the distributive law to multiply, to expand this expression, and let's see what we get. So 900 times 50 would give me 45,000, and 900 times 2x would give me 1800x. Negative 20x times 50 would give me negative 1000x, and negative 20x times 2x would give me negative 40x squared. Now what I'm going to do is I'm going to collect like terms. So R, my revenue, is going to be equal to, I'm going to rearrange it so that I have the x squared term at the front. So it's going to be negative 40x squared. And I'm going to put these x terms together. So I have 1800 and 1000. So it's going to be, in total, it's going to be 800. So I have a negative 1000 and positive 1800. So it's going to be positive 800x, and I have 45,000, so that's going to be positive, that's 45,000. So now I have a quadratic relation here that I'm ready to work with. Now what I have to do is I have to find the price of a laptop to maximize the revenue. To maximize the revenue, I would have to find the maximum value. In other words, I have to change this into vertex form using completing the square and then find the value of x that would maximize the revenue. So what I'm going to do is I am going to take the common factor out because I need to have 1 as the coefficient of x squared. So let's factor out negative 40 and let's see what I have for the first two terms. So I have x squared minus, because I'm dividing it by negative 40, minus 20x. So that would be for the first two terms, and 45,000 is still there. Let's write that. Now what I have to do is, inside the bracket I have x squared minus 2x. So what I have, 20x. I have to find the third term that's going to be added to that to make it a perfect square. So let's think about what it's going to be. It's going to be half of 20, which is 10, and then we have to square it, which is 100. So let's add and subtract 100 to these two terms. So I'm adding 100, and I cannot just add because I cannot make a change. I have to negate that change by subtracting 100, and I have 45,000. Now what I have to do is I have to write whatever I have inside the bracket as a perfect square, and that would be x squared minus 20x plus 100. I'm going to group these, and I'm going to take this negative 100 out, which is going to be positive 4,000. So that's going to go with the 45,000 that I have outside the bracket. So let's write that. So that's taken care of. Now I have to write whatever I have inside the bracket as a perfect square, which is going to be x minus 10 whole thing squared. And now I'm going to add these together. That's going to be 49,000. Now I have changed the expression into vertex form, which gives me the maximum of this of the revenue. So the maximum point here is 10. So it's going to be the opposite of what I have in the bracket, and 49,000. So the 49,000 would be the maximum revenue that I get, and the number of price reductions that I'm going to have to maximize the revenue would be 10. So we know the value of x. So x is going to be 10. Now what the question is asking me is, it's asking me to find the price at which we have to sell the computers to maximize the revenue. So I have to, let's look at the expression that we came up with for the price of a laptop. So 900 minus 20x, because we're doing x number of $20 reductions. So if x is 10, we have to do 10 $20 reductions. P, which is the price of a laptop, is going to be 900 minus 20 times 10, because that's what we found for x. And that's going to be 900, 20 times 10 is 200. So that's going to be 700. So that means we have to sell a laptop at $700 to maximize the revenue. So let's write the final statement. Therefore, they should sell the computers for a price of $700 to maximize their revenue.